Today I'll be explaining the Cybots 2016-2017 drive base for the Velocity Vortex Challenge. This year we began designing our drive base over the summer ahead of time so that we could begin machining all of the complex parts for the gearbox without cutting into the season time. So here you can see that we went with a 6-wheel dropped center design, and we did this so even with a heavy robot we'd still be able to turn very quickly on center by having the omni wheels in the corners and the center wheels dropped by 3/16 of an inch. The thing that makes our drive base most unique would be the shifters, and this allows for us to have 2 speeds and a 3 power takeoffs to go into a lifting winch. Here we can open up a drive pod, and you can see that we're using 3 motors per side, with one being direct driven into the main gear, and so this front motor on each side is always connected to that drive side, so that if the shifters were to fail, we would still have control. We're also using 2 motors here in the back. This far rear one is used for a sweeper in the front, which you can see with this sprocket here. This is chained all the way to the front for our sweeper on our Velocity Vortex Robot, or it could be used for another function. And then these rear 2 motors in their second output are geared together across to the other side to combine in with the motors over there to give this center winch either 3 without this or 4 motors of total lift power. For the Velocity Vortex Challenge, we did have to take out this 4th rear motor to put onto our turret, and so we only had 3, but the design is capable of all 4 motors. You can see with how this gear here is geared all the way across the other side. The center shaft here would be rotating, as well as the gears on this side, whereas the drive gears are connected together here with the rear set of gears here and here and here are connected together, so these allow it to connect down to the main drive wheels. Now, to get into more of how the gearbox works, we'll go into here. So to see inside the gearbox here, we're connecting the either rev motor or a Neverest 40 directly into our Vex ball shifter using this custom adapter piece we made. And what we did with this piece is we didn't want any slipping to be possible with set screws, but we didn't have room for a regular nub or D-clamp, so we chose to make our own clamp that would convert from the 5mm hex or the 6mm D-shaft directly into a 1/2-inch hex for our ball shifter. We did this by machining a square-shaped hole with a very small cutter so that we would have clamping force on 2 sides of the shaft. With these gears, you can see with the main drive gears, they immediately go into this shaft that's hidden inside the gearbox. So these gears are actually connected within, and this allows for a very compact design. Once these gears come out the bottom, they're able to connect down to the 2-speed shifter, which you can see here, where the gears connect right there. So this allows us to have our 2 speeds and then have the shifting rod be right here. Once this comes down to the bottom, it's directly driven into the wheels with a hex shaft inside of the tube. It then is belted from the center wheel to the external wheels on the outside corners. These are the gears used for the winch. in the full assembly. And this rear gear is separate, it just connects to the sweeper. For our actual shifting, we're using a spring-loaded shifters on the outside with a cam in the middle. We went through many different versions of different shifter designs. At first we started with a linkage that would pull the shifters in and out, but we found that the linkage often had issues because it would more of pull the shifter to the side rather than straight in and out. And so this led us to developing a rack style design, and we 3D printed a rack piece so we could have a gear on the central servo that could pull both shifters in and out at the same time. But this also led to problems because our printed part was breaking the teeth off of the rack. So this led us to switch over to a cam based method. So with this we had a spring coiled up between this block we printed and this bearing surface, and so this would always be trying to push the shifter out, but then it was held in by this cam in the middle. So when we wanted to shift into one gear, we'd rotate the cam so it's pushing the shifters out into the internal gear. When we were ready to shift into lift, we would rotate them to the middle position so both shifters could be all the way out and it could engage into the lift. And that's all we have for today, explaining our 2-speed shifting and power takeoffs on our 2016-17 drive base. If you have any questions, please comment below and we'd be happy to answer them. Thank you.